You want to, with your qualitative, by the way, whoever's listening on this, if you're watching it on thing, I missed the first part of this, so you might want to go to a different period. Okay, watch it. All right, so qualitative is what do I see? What am I observing that cannot be measured? Is there a color change? Is it bubbling? Is it giving off heat, but I don't have a thermometer to record the temperature? Anything that I could visually see changing. Okay, I'm writing it down. All right. Quantitative is things I can measure with numbers. So quantitative is I've got a scale and I'm measuring it, like we did with the measurement lab. I've got a ruler, I'm measuring it. And I want to pull off with quantitative data as many significant figures as I possibly can. Now, that last lab, the measurement lab, I wasn't looking for the numbers you had down. I was looking for the place value that you had down. So I know what my rulers can measure. I know what those scales can measure. And if you weren't giving me that information, the graduated cylinders, there were certain things I was looking for as far as how many decimals after, or how many places after the decimal did you have. If you didn't have that down right, you were knocked down. If you didn't put the label, milliliter, centimeter, down, you were knocked down. Because this is really important with quantitative data. You need to write as many significant figures and what unit. Remember we talked about how big the room is? If you give me 12.5, I'm going to go, great, what unit? Yards, meters, hectometers, decimeters, what did you use? Okay? All right, going on. Once we get all that data down, then we do analysis. So this is a little bit different than what you've done before. You probably data and analysis went together, but we separate them. So analysis is when I take any of that data that I grabbed from lab and I do any kind of mathematical equation to it. It's where I make my graphs. Okay, it's any computations. Analysis is any kind of computations or organization of data. Okay, I'm not writing anything down here, but if you need it, write it down. Okay, so it's not just graphs. Okay, it's any mathematical equation or computation, anything that you do to it. So if I take two numbers and times them together, or two numbers and divide them, that's an analysis. Okay, because I'm doing something to those numbers. There are several different kinds of bar graphs, and depending on what kind of data that we're analyzing, depends on what kind of graph you want to use. Bar graphs are great if I'm comparing things to each other. So how did this compare to this, compare to this, compare to this? Okay, so for instance, what kind of pet do you own? A rabbit, dog, cat, goldfish, or hamster? I'm comparing the class. Pie graphs are great if I've got 100% and I'm trying to divide how many got each. For instance, student grades. How many get D's? How many get A's? How many get B's? How many get C's? Okay? So that's an easy way to see that. I think I put it on the next page. The other kind is a line graph. And this is good if I am over time trying to figure out something. So if I'm watching temperature over time, or I'm watching, we'll do labs later with pH. If I'm watching pH over time, I can graph it and I can see what happens over time. Okay? There's also, besides line graphs, there's geographic maps where we actually look and say, oh, pH here is something, pH here is something, pH here is something, pH here is something. It must be something near this site that we took a test that's causing problems. So we look at it geographically. Okay, so going down here, when we do a graph, there's some things that we need to talk about. A graph always has to have a title. Okay, you need to tell me what's in that graph. Just like on the other ones on this page right here, where it said, excuse me, what kind of pet do you own? Student grades. It gives me a clue as to what you've graphed. On this one right here, small town teens with cell phones. Cell phone use in any town USA. So I sort of know what I'm going to be looking at. We need to label the x-axis and the y-axis. Got to tell me what you're plotting. Don't just put numbers and assume I know. You guys know what assume means, right? Okay. All right, you got to give me a key too. You got to tell me what what if there's more than one thing on there, what you're graphing, what color what means. Okay? Otherwise, it doesn't mean anything. All right. Conclusion, 5 sentences. I'm going to drill that into your head. 5 sentences in your conclusion. Tell me what happened. What did you get from what happened? What do you think from what happened? How does that go with what you've known in the past? Okay? Take those questions and write a sentence with them. Some of you are very inventive when you were writing your 5 sentences, and you come up with a noun and a verb, done. A noun and a verb, done. A noun and a verb, done. And I'm going, okay, we need to talk about this. It needs to be more than a noun and a verb. You can't just say, temperature changed. Time went. You've got to give me a little bit more, okay? Then we have error analysis. We're going to be doing a couple things in error analysis. Number 1, you're always going to give me an error analysis saying what could have gone wrong, what did go wrong. Okay? But then we're also going to get to a point where at the end of the lab, I'm going to say, okay, this is the answer you should have got. What's your percent error? Does anybody know how to find percent error? Okay, so to find percent error, if you want to do redneck, okay, it's what I got minus what I should have got divided by what I should have got times 100. So in other words, the difference between what I got and what I should have got divided by what I should have got times 100. Don't even bring an English teacher in here. It'll never work. Okay? So the difference between what I should have had and what I got divided by what I should have had times 100. So got minus should have divided by should have times 100. Now, I'll tell you to do that absolute value. Okay? In other classes, like if you go on to biotech or that, they will want to keep that sign there to tell you what way of the answer were you. I just want to know how far off were you. What percentage off were you? Now, in a lab, as long as you're under 20%, you're not fired. If you're under 10% error, you're usually given a raise. Okay? Over 20% error, you're shown the door. Okay? So we want to try and keep our error under 20%. Okay? Now, some labs I'm going to tell you, you're going to be off. I know you're going to be off. But we're doing this lab because I need you to learn these techniques. We don't have the equipment to make it under 20% because it's way too expensive. But we can get around there. Okay? So I'll be accepting bigger percent error. Now, some words that we need to know. Precision and accuracy. I like to, let's see, I think they're in here. Didn't get everything out like I should have. Yep. I guess we'll just do, oh, there's 1, 3. Heads up. Heads up, 7 up. Okay, I'm going to show you with accuracy and precision. I've got 3 things here. And I am going to shoot for you, Lacey. Okay? You ready? Everybody watching. Otherwise, you might get hit up upside the head because I'm not a really good shot. Ready? Oh! Okay, was I accurate or precise? I was accurate? I hit her? No. Did you get that other one over here? Will you guys find these for me and bring them back up? I know, you don't want me throwing stuff again, huh? Okay, so we're going to do it again. Heads up. You're going to head on the side of the head or in the neck. Okay, ready? Ready? I was precise, but I was still going for Lacey. Yeah, I was still going for Lacey. Lacey's still the one I'm trying to hit. So what was I? Was I accurate or precise? Precise. So if I'm in lab and I'm doing the same wrong thing every single time, I'm going to get the same answer. I'm going to go, yes, I got the same answer. But it's wrong. Right? Okay, so I'm going to go one more time, Lacey. You ready? Okay. You're not ready. You're not catching. Okay, what was I that time? I was accurate and precise because I went for what I was doing. Okay. And I hit it, even though she didn't want to catch it. I should have gone for a guide. It's all right. Okay, so this sort of tells you what's going on. Now, I can be accurate once, and the rest of the time, all over the place. Okay? So I can be accurate once and not precise. Does that make sense? Doesn't show it here. But if I'm accurate and not precise, what does that tell me? If I'm shooting a gun or shooting bow and arrows, what does that tell me, guys? If I'm accurate once but not precise, so the rest is all over the place, I suck. And that means I'm not holding it steady, right? I'm jumping, okay? If I'm precise but not accurate, like this, when I'm shooting a gun or I'm shooting my bows and arrows, what does that tell me? If I hit the same spot, but it's not where I'm shooting, what does that tell me? I'm consistent. My sights are probably off. I need to fix my sights. I need to re-put in my sights. Okay, so let's go on to the next one. Okay, now we've got physical and chemical that we need to talk about. And this lecture sort of jumps around a little bit. When I'm talking about physical and chemical, what I want to talk about is how do I tell the difference? Because I'm going to be giving you scenarios, and you're going to need to tell me it's physical property. No, it's physical change. No, it's chemical property. No, it's chemical change. So physical property would be color, melting point, boiling point, phase, anything I can basically observe. Okay? So physical property is something I can observe. A physical change would be like tearing a piece of paper. It's still paper. Or cutting a piece of paper. Or changing from a gas to a liquid, because that's what we call a phase change. I can still get it back as long as I heat it back up, right? So a phase change is known as a physical change. When I get to chemical property, this is how something reacts with something else. So for instance, a couple years ago they put a new top on the Capitol, which was copper. And it was bright and shiny copper for about a year and a half. And then it started turning dull and then went green. And that green is copper rust, which is called patina. Okay? It reacted with the water and the oxygen. So copper reacts with oxygen and water to make patina. So a chemical property is how does it react with other things? Or how would it react? If I put potassium in water, it will go around with a purple flame, spitting sparks, and all of a sudden go boom. Not real boom, but big, but a little boom. If I put cesium in water, then I've got a real explosion. Okay? If I put zinc in water, nothing will happen. So it won't react. If I put zinc in hydrochloric acid, it bubbles like crazy and gives me hydrogen gas. So chemical property is how it would react. Chemical change is when it actually does. So this would be like wood burning, and I get charcoal. Okay, that would be a chemical change. When I open a bottle of pop, in the bottle of pop, in the solution, there's carbonic acid. And then I open the bottle of pop, you get that fizz, right? That fizz is that carbonic acid decomposing into carbon dioxide and water. And if you leave it out too long, the pop goes what we call flat. And the reason why it goes flat is that carbon dioxide went out, and what it left behind was water. So it dilutes the syrup that was there. So the flavor doesn't taste the same. So pop fizzing. Whoops. Color change. Temperature change. In a reaction, if it's just temperature change for a phase change, then it's not. Okay, yes? It's chemical. Okay? Well, let me come back on that. It's a chemical change for the popcorn kernel. For the water that's inside, it's a physical change, because that's what actually makes the popcorn pop. Is you had water in the kernel, and when it turns to steam, phase change, popcorn kernel pops. But in the process, the kernel itself changes, and you can't get the popcorn kernel back. So that's a chemical change. So you got two things going on. Okay? Does that give you an idea? I didn't give you every example there is, but a chemical change, for the most part, it isn't reversible. We'll get to some that are reversible, but for the most part, isn't. Okay? So density. How many of you know the equation for density? Good. Density is equal to mass divided by volume. I like to look at it like this. You're a little dense if you're in love. Mass over volume. Okay? Right? You don't see things the way you should because you're a little dense, you're in love. All right? So, we're going to be working with this in the next couple days. Mass divided by volume. Usually in grams per milliliter or grams per centimeter cubed. When I have a weird shaped object, as long as that object is waterproof, meaning not wood, okay, and it will sink in water, because that's important, because if I put like a styrofoam pebble on water, it's not going to tell me the difference. And I take the measurement before I put it in the water, and after I put it in the water, I can take the difference and find the volume of that unusual shape. And we're going to be doing that in lab. Okay? So that's how we find displacement. What I started with before, so I'm going to have to write it down, what I started with before, what I started or I ended with, and then analysis is where I would subtract them and find the volume. Does that make sense? So anytime I have to use a mathematical equation, I put in analysis. Okay, so let's do some problems here to work with. What is the density? So I'm looking for density of a metal that occupies 3.4 centimeters times 4.5 centimeters times 5.6 centimeters and weighs 56.4 grams. Okay, what do I need to do to find the volume? How do I find the volume of a cube? To find the volume, I go length times width times height, right? So to get the volume, and this is in your thing, so you might want to write some examples down. 3.4 centimeters times 4.5 centimeters times 5.6 centimeters. Now, how many brought calculators today? Get them out. How many got phones today that have a calculator on them? Get them out. How many don't have either of those? Come borrow a calculator from me real quick. And you just need to make sure you put it back. They're down here. Hopefully I didn't replace the batteries, so if they're not working, come bring them back and put them in a pile on the side. How much? 35.6, 85.6872. Oh, centimeters. Just centimeters? Okay, this is where we need to use our significant figures that we were working with last time. How many do I have here? 2. How many do I have here? How many do I have here? How many can I have here? 2. So I'm going to report 86, right? And it's centimeters times centimeters times centimeters, which means it's centimeters cubed. That's my volume, right? Everybody okay with that? Whoops. Yes. I have to look and see how many I had each time. Each time here I had 2, 2, 2. So I put this in my calculator, got the answer, and I say, okay, I only have 1, 2. I look here, it's bigger than 5 and round up. Okay? So the other thing I have is grams. Now, what was the formula for, did you have a question, Jackson?
So if one of the first numbers had 3, you would go 3 numbers.
Nope, 2. Always the smallest when I'm multiplying or dividing. So if it had 3, 2, 2, I'd report 2. Okay? Good question. Who remembers the equation for density? Remember your dense if you're in love, so what's on top? Mass. Okay, so density is equal to mass divided by volume. Here's my mass, 56.4 grams. Here's my volume, 86 centimeters cubed. What am I going to get for my answer, and how many significant figures should I give it? Dakota, do you not have a... Okay, whenever you do that, just go grab another one and write in another one and just put them together. Because otherwise you're going to... Well, I guess you could write that at home if you want, but... Write on a scratch, whatever. Okay, anybody got the answer? I'm going to wait until you do. 0.6, got to be slow for me. 558. Good enough for right now. Units here would be grams per centimeter cubed. Is that the answer I report? Okay, what do I report? How many significant figures do I have? How many here? How many here? How many to report? 2. So 1, 2, rounded up. So what do I report? Grams per centimeter cubed. Okay. All right, let's look at another one. Okay, what would the volume, so this time I'm looking for volume. Would a liquid with a mass, so here's my mass, and a density, so here's my D, occupy. Now, you'll notice I do this. I hated story problems when I was your age. I hated them, absolutely hated them, until I had a teacher that told me, well, just take it apart. As you read it, circle and label things, and then it's easy to pull them out. Okay? So, okay, density is equal to what again? Mass divided by volume. And this time I'm looking for volume. So these two will trade places. I'll get volumes equal to mass divided by density. Okay? I've got everything, I just need to plug it in. So, plugging it in, my mass is 6.54 grams divided by my density, 1.23 grams divided by milliliters. Grams will go out. I'll have 1 over milliliters, 1 over milliliters, which equals a milliliter, because it flips it to the top. So I'm going to put milliliters out here. How many significant figures should I report to? 3, good. There's 3 here. There's 3 here, so I can report to 3 over here. What's my calculator answer? What's my calculator throw up? Come on. That's why I had you get your calculators out. Or phones. You can do this. You're going to need it for today's work, so 5.317. So what am I going to report? 1, 2, 3, rounded up, 5.32 milliliters. Okay, Kent, are you awake? Okay, let's take some notes. All right, going forward. What would the mass, so this time again I'm looking for mass, of a piece of plastic with a density of an irregular object that is placed in a graduated cylinder containing, and again, I'm a very visual person, containing 200, and the volume increases to 278, both of those milliliters. So the difference is what? How much did it go when I put that in? 78. And what is that? What's that equal to for me? What does that equal to? What does that give me? Density, mass, or volume? Volume, good. Okay, so again, I've got the equation density equals mass divided by volume, but this time I'm looking for mass. So mass is going to equal density times volume. So plugging in, mass is equal to density, 3.542 grams per milliliter, times by volume, 78 milliliters, equals, mass milliliters go out, so I'm going to end up with grams, which is what I want. Okay, somebody throw that through your calculator. Give me that calculator throw up. Let's see what we got. .276. Okay, so let's look at how many significant figures. This one had how many? 4. This one had how many? 2. So overall, how many can I have? 2. 1, 2. I look at this one, round up. So I'm going to report 2, 8, but I've got to do something else. What? I've got to put a 0 right here because I've got to hold the place. I've got to tell how big that number is. And then put the grams. And I'm done. Okay? You're not writing it down. You remember this? Guys, remember, you guys get credit for taking notes. If you don't take notes, when test day comes and you turn in your notes, you're not going to get credit for your notes. So make sure you're taking notes. Yes? Say it way loud for me. When you go and you solve for mass right here, you're actually going to times both sides by volume. Volume will cancel. And so it'll end up being density times volume, and that's what we did. Okay, yes?
So why did you get the 78?
So the 78, I took this number. They said that's what I started with. And then I went to this when I put that object in. So I put that there, and then I just subtract the 2 to get the volume of the object. Okay, we okay to go on? Get this? Okay, you're good. Now it's your turn to work on your daily assignment 3. Get going and bring the joy. Okay, so you have a lot of time to work, so you should be able to get this finished. If you were not brave enough to come up and get a calculator before and you need a calculator, come borrow a calculator. All I ask is that you put them back. Okay? You definitely need to get a calculator if you haven't got one, though. Did Megan ever come in, or Dylan? Kent came in, right? Yes. Dylan, are you? You're what? Thank you. Stop the